With the quadratic formula, we solve the general quadratic equation, which you see right here, ax squared plus bx plus c equals 0, once and for all. And that solution looks like x equals what you see right there, negative b plus or minus the square root of b squared minus 4ac all over 2a. We derive this formula by using the completing the square process to help us isolate x. And I'm assuming here that you have thought about the completing the square process before, and that you understand that process. We just do a brief reminder of the steps. To set up for the completing the square process, we need to get the left side of the equation to look like 1x squared plus something x, and then equals everything else on the right hand side. So a good first step would be to subtract c from both sides. Now to get a 1 for the coefficient of x squared, we'll divide the entire equation by a. So we'll divide on the left, we'll divide that first term and the second term by a, and then the term on the right we'll divide by a. Alright, so we've got our 1x squared, and then we need to complete the square, and we take half the coefficient of the x term, that is half of b over a, which is just 1/2 multiplied by b over a, or b over 2a. We take that quantity, b over 2a, and we square it. And then we're going to add that b over 2a squared to the left side and the right side of the equation. This maintains the balance of the equation. Okay, we set ourselves up on the left with a perfect square trinomial. That can be rewritten as x plus b over 2a. That entire quantity, x plus b over 2a, is squared. That's equivalent on the left. And now we're going to go to the right and try to simplify that expression on the right. We're going to find a lowest common denominator, and we'll do a little calculation before that. We've got that square term, so we'll change that to plus b squared over, take 2a and square it to get 4a squared on the right. And now let's look at those two denominators, 4a squared and 4a squared can serve as the lowest common denominator there, which means we're going to multiply the numerator and denominator of the left expression by 4a. So we get negative c times 4a and a times 4a. That gives us a 4a squared in the denominator, and we now have a common denominator. Right, some people have trouble with this process, so let's take it a little slower and more carefully. On the right-hand side, we're combining the common denominator of 4a squared, and we took that left expression, negative c over a, multiplied numerator and denominator by 4a. That gives us negative c times 4a in the numerator. We're going to rewrite that in a minute as negative 4ac. It gave us a 4a squared in the denominator, and then b squared over 4a squared we won't change. So we have the common denominator, 4a squared. So we can make that one fraction, b squared minus 4ac, all over 4a squared. Remembering that that negative c times 4a became negative 4ac, and we rewrote with b squared up front, b squared minus 4ac all over 4a squared. The middle equation here is what we just came up with. Now we're set up to take the square root of both sides, and we're doing that so that we can move toward our goal of isolating x. We can take the square root of both sides of this equation. On the left, we'll get the square root of that expression, and on the right, we'll get plus or minus the square root of that expression. We know that when we take the square roots of things, we frequently get two square roots, a positive and a negative one, and with these variables, we're not sure what the case will be, so we use plus or minus to kind of account for both possibilities. So we get x plus b over 2a on the left, as we designed it to do. And on the right, we just carry that along, but we're going to simplify a little bit by applying the radical to the numerator, square root of b squared minus 4ac, and then apply the radical to the denominator. The square root of 4a squared we can write as 2a. Now there's a little bit of an issue we're glossing over, and that is usually we'd say the square root of 4a squared would be the absolute value of 2a. But because of the plus or minus, that's being taken care of here, and we don't have to worry about it, and we also don't have to worry about it on the left. Okay, we're close. We want to isolate x, and we'll do that by subtracting b over 2a from both sides, which is of course the same as adding the opposite of b over 2a to both sides. So we'll end up with x on the left and the opposite of b over 2a, negative b over 2a, on the right, plus or minus that expression just as it is, b squared minus 4ac all over 2a. And we've actually landed at a good expression of the quadratic formula. But the more typical one has a common denominator of 2a. So as we move to the next slide, you'll see our equation from the previous slide in the middle, and then we combine those two terms on the right over the common denominator 2a. And we get the famous quadratic formula, which is a solution to the general quadratic equation ax squared plus bx plus c equals 0. We've done that once and for all. This is all the possible solutions. And we've done that using the completing the square process. With the quadratic formula, we solve the general quadratic equation, which you see right here, ax squared plus bx plus c equals 0, once and for all. And that solution looks like x equals what you see right there. Negative b plus or minus the square root of b squared minus 4ac all over 2a. We derive this formula by using the completing the square process to help us isolate x.